Welcome to everybody who's already here. We'll be starting in a couple minutes at 12. All right, it's 12 o'clock exactly, so we're going to start here. It's no problem if others join us at a later point in time. We'll make sure the whole webinar is recorded and shared with you all afterwards, so you can watch parts back that you found particularly interesting. And the slides are obviously going to be made available to you as well, so that should be no problem. Welcome. In this webinar, we will be talking about the digital product passport in the circular economy. Your hosts today are my colleague, Rens van der Born. He grew his hair out a little bit, but it is still him. And me. Rens is going to take over about halfway through. It's good to know that this is the first in a series of webinars. We'll come back to that a little bit later on as well. And today is all about introducing the concept of the product passport and placing it in the perspective of the circular economy. Why did we develop a digital product passport? Why did others develop digital product passports? And what can we do with them for the coming years to make sure that we make a sustainable transition? First off, we have some new visitors. Yes. So what's on the agenda today? I will introduce the circular economy very quickly so we can funnel to the digital product passport and discuss what its relation is to that circular economy. We will discuss circularity and applying the digital product passport in a supply chain. And we have a couple of use cases that we would like to highlight to demonstrate how it works in practice. And at the end, we will have some time left to discuss questions, but feel free to ask anything at any time in the chat. Rens will be monitoring the chat while I'm speaking, and I will do so when he is speaking. And as said, we will be hosting more webinars over the coming months, and we are always interested in hearing from you guys what kind of topics you would like to see discussed. We have our own ideas about that, but suggestions are always welcome. Yeah, so let's get right to it. A quick funnel. Where does this whole discussion about the digital product passport start? Well, to put things in perspective, we like to start at the SDGs, the Sustainable Development Goals, set up by the United Nations, and they sort of have to serve as a way, as a path to face the challenges that the Earth is facing. You probably are all very much aware of Earth Overshoot Day, the moment in time in which during the year we have used up all of our resources that the Earth has to offer, and that's sort of a good starting point to start a discussion on the circular economy and digital product passports. We do not have enough critical raw materials, for instance, to answer the demand of our economy, of our worldwide economy, to make a sustainable transition, to make sure that all the appliances that we use and all the products that we want to make can be made. Of course, it's very obvious that whatever products we use, whatever products we make, they go with a certain emission that affects global warming. So if we manage to tackle some of these challenges, we automatically reduce our environmental footprint, and therefore we need to find ways to become more sustainable. Our focus is on materials. And why is our focus on materials? If we look at the impact of, let's say, traffic movements compared to the impact of materials, materials are far more relevant. They are a very big contributor to emissions worldwide. And they are a very good way to tackle this problem. It's a very practical way of approaching this problem of global warming and all the other challenges surrounding it. That's what this image is about. It's about emissions that we want to tackle. Then there are a few other arguments why it's very relevant to focus on materials and communicate your use of materials and the impact that those have to customers and other parties in the supply chain. First off, there are not only critical raw materials that are hard to come by, but a lot of materials have become very scarce and expensive for a number of reasons. They might be geopolitical, but there are a lot of reasons why materials have become more expensive. So it makes sense to keep track of what you're using and to recover as much of those materials as you can. Secondly, there's demand by customers, by the market. People want to have insights into the impact that they have with the products they buy. And for some companies, that might mean that the companies that buy their stuff want to know what contribution they're making to their sustainable efforts. So we want to create transparency about those factors. Thirdly, legislation is already in place and on its way, both on a European scale and a national scale. There are numerous legislative initiatives that require either to communicate about impact, but also the digital product passport as a concept itself is on its way. It's starting with mandatory digital product passports for batteries. That's probably going to happen officially next year, but it's going to be rolled out for more and more product categories. So that's also a good reason to make a start with it. But as illustrated in this picture, there are many reasons why you would want to start using digital product passports. And that's our starting point. It's good to mention that in this presentation, we try to give an overview of the digital product passport as a concept in the circular economy. But we created one ourselves, so there's always going to be some very specific elements that we use that others might not use, because we're not the only ones. But you might all be aware of LCA's lifecycle analysis. And before we dive into the digital product passport, I did want to take time to sort of dive into the differences and similarities between the two. So that's what we're going to do here. First off, a very simple definition of the LCA compared with the digital product passport. An LCA is an impact assessment of products, processes, and services. That's as simple as we can make it. The digital product passport, on the other hand, is a digital environment in which product data and information can be shared. Now, we can make that more specific. If we look at what both do, well, both contain environmental product data. So that can be about materials, that can be about movements of materials between sites, but they both contain that kind of information. They both express impact in KPIs. Now, even within LCAs, there's a big range of different KPIs that are being used. In some, they might use 15, in others they might use 20. And the same goes for digital product passports. Not all passports have the same KPIs. And thirdly, both are a means of communication on sustainability in the broadest sense. And we have to say that this is in the broadest sense because there's so much variation between the various lifecycle analyses and the various digital product passports. One thing that if we look at strictly what an LCA is and what a digital product passport is that an LCA is a static document. You make an LCA once, and that can be valid for a certain amount of time, but it's never a dynamic document. And the digital product passport has to be a dynamic document. We'll dive into the reasons why it has to be later. But there's some misconception in the market about some digital product passports that claim to be digital product passports, but in reality are just a digital version of the LCA. So as long as it's a static document, we can only speak of LCA. I've noted here that an LCA has an expiry date. That can be both a literal expiry date, so we have this LCA and it's valid for 5 years, but it can also be an expiry date in practice. Imagine you've made a bicycle and you change certain parts, certain elements of that bicycle. Well, that LCA that you made of the original version is no longer an accurate version of reality. The digital product passport is dynamic, as said, and it has no expiry date because you can change elements and you can directly use that in that digital document. Another difference is that an LCA is usually about 30 to 80 pages, depending on the product, depending on who does the LCA, which makes it very interesting. It has lots of relevant information, contains lots of relevant information, but it's not as easy to understand for the consumer, and it might not always be as practical as you want it to be. And the digital product passport, in essence, has to be one overview with all relevant data that you need. Lastly, a lifecycle analysis is usually done by an LCA consultant. Doesn't have to be. And digital product passports should be do it yourself. Although in practice we see that sometimes, well, in our case, we create them for customers, or customers want us to create them. So that happens as well. But in essence, these are the similarities and differences between the two. So if we talk about digital product passports in a circular economy, we have to look at why we would need a digital product passport. It's another thing we have to do. So why would we? Well, the essence is that circular products can only live up to their potential with an underlying system. Actually, they can only live up to their potential with several underlying systems. If you created a circular bicycle and you've designed it to be taken apart and to be recycled, refurbished, whatever you want to do, you have to make sure you organize your reverse logistics, because you have to make sure that you can actually reclaim all of these parts. But you also need a tech system to document what has to be done at each step in the supply cycle. That's one of the problems we see with the LCA, as we just discussed it, that it's a one-off document that is not carried with the product throughout its life cycle, which makes it very difficult to follow up on circular promises. It can be designed for disassembly, but if we don't know how to take it apart and where to bring it, how can we live up to its expectations? So that's a very important aspect of why we want to use the digital product passport. Now, what does it capture? Our digital product passport captures material composition, and it does so on one or multiple levels. As you can see in the image right in the middle of the screen, a bicycle can consist of several different components. Think of a bicycle frame, its wheels, and its battery. You can create this layered view of your products. And you want to do so because not all these elements might have the same destination at the end of a use cycle. The bicycle frame might be able to be refurbished, while the bicycle wheels have to go into a recycling process or are downcycled at the end of one use cycle. So it's important to understand that role of the product passport. Product composition is what I just try to explain, is that there are different layers to a product, and that because all these layers might have different destinations, is why you want to create an overview of that. Thirdly, we have the defined use period. Obviously very relevant if you work in a circular economy where you try to extend the life cycle of products and materials for as long as possible, because if you use products for a longer time, they automatically have less impact because you don't need to replace them with new stuff. So that's also something you want to record in the product passport. Next, we have the ability to document information on, for instance, reverse logistics, disassembly, refurbishment, recycling, technical information that's often necessary for producers and sellers of products, but also additional leaflets, for instance, how you as a company deal with carbon compensation if you do so. Obviously, not all of this is necessary. If you have processes like these in place, you can make sure that the relevant information is in the digital product passport. You can disclose this kind of information by adding links, so a URL, but you can also add actual documents, so downloadable documents to the passport. Next use applications are absolutely necessary to record in the passport because, like I said, if you have a product that is not 100% recycled at the end of a use cycle, you want to indicate where the different material streams end up. So in this example, we have 60% is going to be refurbished in a new e-bike, and 40% might be recycled with various applications. And then you obviously have the possibility to go into further detail about what these various applications are. And then lastly, the derived impact data. So based on the materials that you use for your products, but also their next use applications, you want to create insights into what the relevant impacts of these materials and products are. And we do so, like we discussed before, with a couple KPIs. In our product passport, we use CO2, energy impact, H2O impact, raw materials saved, and we also made a connection to the carbon price, and we offer the possibility to add social return on investment to the product passport. So that's a very brief overview of what they should do. Yes, we will discuss questions later on, I think, or Rens, if you have a quick answer, you can already do so. Okay, then I want to make another step into why we want to use them, because I've discussed what's in a digital product passport. what are all the functionalities of a digital product passport, but what does it do? What does it bring us? Well, one of the things it does is it makes circular progress visible. Um, this will become even more clear in the use cases we're going to discuss. But one of the things you can do with digital product passports is communicate about your material composition of products, indicate what materials are already recycled, what materials are still virgin, and what you do with these products and materials end of use. We understand that it's not a transition that you can make from one day to the other. So it's very good to show your customers and all other stations within the supply chain where you are making steps. Secondly, you want to be honest about impact. You have to be, but you also want to be honest about the impact that you make as a company. So by recording all your materials and products into passports, you have a very quick way of generating impact figures, where if you would use LCAs, it would take a lot of time. It's a pretty costly and time-consuming affair to create LCAs for every single product, especially if you have hundreds and thousands of products. It's next to impossible. But you also want to comply with upcoming or already or legislation that's already in place. We are closely following the developments in the European Union. As of now, the digital product passport is not bound to very strict requirements. It's obviously something that has to be easily accessible, and there will have to be environmental impact information within the digital product passport. But the European Union itself is not set on what it has to look like exactly. Now, you could choose to wait and see what happens, but in our experience, it's much more fruitful to start using the digital product passport and develop it as we learn, to create volume and use that volume to also inspire the European Union to take the right steps into legislative measures. Okay, then improve with insights, something I sort of touched upon before. Because we can generate very quickly generate data on the impact of products, it becomes very easy to improve products using that data. Take the bicycle as an example. If you know that you're using virgin rubber and maybe a virgin material made frame, you want to make choices that have the most impact, well, then simply calculate within a digital product passport what the impact would be of using a certain recycled material for the frame or using a recycled material for the wheels. So it can help you make the right choices in your product development towards becoming a more sustainable company. Another important reason why you want to use the digital product passport is to substantiate CSRD reporting. I'm sure it's clear to all of you that greenwashing is still a pretty big problem. And also in this field, we can see that there's quite some legislation and regulation upcoming in the European Union, and we applaud that. We're very happy about that. But we do want to give companies the tools to substantiate their sustainable reporting. So we see that a lot of companies are already at the stage that they have very good plans, that they have very good ideas on how to become more sustainable. But it's very difficult, even when using LCAs, because you would have to do those several times over a period of time to be able to track your progress. Well, this is a much easier affair if you would record your products in passports, and therefore deliver data that you can use to substantiate your claims made. Lastly, you can easily define your contribution to sustainable development goals. So as we can see that a lot of companies already support the sustainable development goals, or at least acknowledge that they have to make a contribution. By creating quick insights into impact of products and materials, it becomes much easier to make to put a number on that contribution that you're making to the sustainable development goals. then we're ready for the next step. Another aspect I already touched upon, but that needs a little bit more explanation, is that we have to think in transitions to make things happen. The example that I'm using here is based on the e-bike that will come back in several other examples later on in the presentation as well. We have customers that know exactly what their products are made of, that can give a very detailed material composition to the level where they know exactly where a certain piece of recycled rubber comes from. But on the other end of the spectrum, you have quite a lot of companies that simply don't know, and they might only know that they have products that are made of metals and rubber. One way to see this problem is to sort of do nothing and accept that you simply can't make sustainable changes because you don't know the exact composition of your materials yet, of your product yet. Another way of looking at things is using the product passport as a starting point. So if you only know that it's that your product consists of metals and plastics, or metals and rubber, you have to record that into a digital product passport to then go and look for the specific materials that you actually use. You can specify that in the digital product passport, and the impact automatically changes if you do so. You can then also make the step from, okay, I'm creating one digital product passport for an e-bike, to I'm going to create underlying components and specify their specific material compositions, and therefore create a more accurate image of what I'm selling and what the impact of that product is. And the third step you can take is add recycling instructions and all the relevant information. As discussed, even if you have a brilliant circular design of a product, what happens further on in the supply chain when a recycler has to deal with your product and has to know what possible next use applications can be applicable for this specific product. So that's why we sort of want to inspire our customers, and not only them but the whole market, to think in transitions and to accept that you might not know everything at this point in time, and to try and find the information that you want to know, and use that to create a path towards becoming circular. That's the end of my part of the webinar, and I'm going to give Rens control of the slides.
Yes. All right. On to the next one. So what I'm going to do, Jasper has already mentioned the example of the e-bike, and we will look into the supply cycle of an e-bike in the following slides. So where we start off is the design for disassembly. So we're going to look at what role the digital product passport has in a circular supply chain. And this is the first step, but before engaging in our first step, we kind of have to take some notes into account. And that is that, in our opinion, a fully circular supply chain, or mostly circular supply chain, is hard to realize without a digital product passport, or a similar solution that records absolutely necessary information. We can imagine that working in a supply cycle where we have various actors that are active in this cycle, that the sharing of information is absolutely crucial, and that can be done in various ways. So product environmental data sheets are one of them. We see a lot of those in the current market as well. But a digital product passport can be a replacement for that, because a digital product passport holds more information than the current forms of information sharing we see as of today. Besides that, if a supply chain is only starting to implement circular or more sustainable solutions, the digital product passport can already play a very important role and even speed up the transition towards a more circular supply chain. Because you can actually add the digital product passport or the use of the digital product passport in every link of the chain we're going to look at in the following inputs. So you could think of this in terms of what would be beneficial for the circular economy as a whole, but also think of the business opportunities it presents in every link as well. And we will walk through the steps now. So the design for this assembly is the first step. So in an ideal situation, and sadly this is more often an ideal situation and not entirely practice, but is that we start the supply chain by actually designing a product that is made to be circular. And by that we mean that we have a product that can be disassembled easy, that has materials that can be recycled or refurbished, or at least are actively designed to be incinerated in our last possible solution, which we of course try to avoid. And in our example for the e-bike, that would be a battery that could be easily removed or refurbished, or a frame that can be taken apart with quite easy steps by a laborer, for example. If the design fails to take into consideration that this assembly will be at one point necessary, it becomes much more difficult to implement circular solutions further on in the chain. And in the digital product passport, you can record the product compositions in layers, as Jasper already shortly discussed in an earlier slide. So we can identify what components make, what assimilation of components actually make the product in itself. And additionally, what end-of-use solutions we can identify for the various parts. So the tires might be worn after, let's say, 3 years of use, and can be recycled after, but the frame might be it could be used for a longer period of time, for example, 5 or maybe even 10 years. And this information can all be added to the digital product passport. And because we use the components and products to construct a passport in total, we can separate these kinds of information per component or product for that matter. And by adding this information to the digital product passport, it can become much easier to follow up your circular promises as the product moves up to the supply chain. So the next step of the chain would be to identify the materials that you want to use for making your product. And the choice of these materials has a lot of impact on the many aspects of the circularity. So looking back at the first step, some materials are more easily incorporated in the design for this assembly than others. And secondly, there's a question of recyclability. So to what extent are we able to recycle every material that is part of the components? And because in the end, we want to have the maximum amount of material recovery. In an ideal situation, all of these materials can be reused. So we can reuse, for example, the tires to recycle for recycled rubber, a refurbished aluminium frame to be used in a new bicycle, and we can recycle the plastics that are part of the bicycle as well. So mostly the smaller parts that we see, for example, calipers or fenders and stuff like that. And the possibility to actually use and specify the material information can all be documented in the product passport, as well as the environmental data. So the impact data that is also part of the product passport. If you go into the next step, we're gonna be producing and manufacturing our e-bike. So As discussed in the design for assembly, products are more often made of components, and in the production process of an end product, like the e-bike, parts are usually bought from a number of suppliers to create the final product. So we have a lot of actors that are active making the specific product. If the components don't have passports, you would like to create them in an ideal situation, so you can create a complete overview of the assembled end product you're selling, but also the lower component passports that have a function in them to be recycled in a further step in the supply chain. And in most sectors, it's an obligation by law to produce detailed technical information about the product anyway. So a digital product passport can fulfill this goal as well. So in that way, you kind of kill two birds with one stone. And our next step would be a distribution. And in this specific overview, the distribution is considered to be the step where the product is sold. So that could be by a brand themselves or by a wholesaler. The digital product passport and the fact you have recorded all of the previous discussed information allows you to comply with legislation as a seller. Could also help to make your consumer or customers make product choices, so you can actually inform them on what kind of product you are selling, how it relates to other products that are on the market, and advise, or at least try to steer your possible consumers into buying products. And in that way, we also see that it provides your marketing and communications team with presentable data about your products. Data that, in our opinion, is more suited for the external market than just a material safety data sheet, for example, that also holds a lot of information that is documented in the product passport. After that, we would follow up with use and maintenance phase. So throughout the use phase of a product, there are several ways in which easy accessible information is needed. So as a customer, you would like to know how to handle a bicycle to ensure lengthy and safe, responsible use. And secondly, maintenance is one of the ways in which we can make sure that the circular products and concepts come to fruition. So of course, you would like the product to be used as long as possible, and good maintenance is very important for that matter. So think of the bicycle mechanic that is faced with a range of e-bikes that all have different maintenance needs. If he or she has quick access to the instructions on how to perform a maintenance for a specific issue, it would become easier for them to do their job. And this information can all be added to the product passport as well, which makes maintenance a tad bit easier. So after use, we end up with the end of use process and also the reverse logistics. So by recording the end of use treatment of products and materials in the digital product passport, you can sort of paint a more accurate picture of the impact those products and materials have. And additionally, you can make sure that customers have access to the information that helps them realize the possible treatments. For example, reverse logistics or disassembly instructions is if that's something you would like to add to your product. Almost inevitable step in this process, especially in the starting phase of setting up a circular supply cycle, is downcycling. So if you start out designing a new product, it can be hard to find a second end of use or an end of use solution for every specific product and or material, and sometimes you end up with components or materials that cannot be recycled. So downcycling can be a solution to that, to at least ensure that every single part that is used in the process does have an end of use, that's unfortunately not the ideal situation, but it can be a good solution for leftover parts and materials. After the reverse logistics and we've set up an end of use, we would look at recycling and refurbishment. And during this step, a very important note or a very important theme would be to look at the next use of the material and/or product, because that would actually influence where the specific product or material would end up. So recyclers have a lot of materials for which they often need to test and conduct research to determine how they should treat it. And this often often differs in specific countries as well. So constantly they're coming up new ways of recycling, especially in the plastic sector. There's a lot of oncoming projects for chemical recycling instead of mechanical recycling that can offer new solutions. So it's a constant iterative process where we look at what can be happened or what can be done with a specific material. The digital project passports allows you to disclose information that makes life for the recyclers a tad bit easier. So additionally, they can use the DPP to communicate about material properties of the recycled materials they get, so from the producer side. And also, if a recycler would like to sell recycled materials, they can use a digital product passport to specify what specific recycled material it is that they're selling. For example, a rubber granulate that is made from used bicycle tires. And our last step would be depending on the next use we've selected for a specific material. As discussed in the materials link, a fully circular product would have been made of materials that all are recovered. But if we want to be able to do so, we have to know what every next use would be for a specific material. So it could be that we have granulate material, for example, in a plastic situation where they would end up in a material process again. It could also be that parts of the used bicycle are ending up in the production/manufacturing stage. So that, for example, could be a refurbishment case of a e-bike battery that can be reused as is. So they're going to end up being manufactured into a new bicycle. It could also be that we have products that are actually not been used to that much extent, and that can be distributed as is. So, for example, returned bikes that have wheels that haven't been ridden on, they can just be sent back to the distribution where they can end up in stores as is without the influx of a recycling or refurbishment process. So this would set up the total of the supply cycle. Next up, we're going to look at some small and shortly explained examples of use cases we have handled in the past. So, for example, a use case would be the end of use implementation of textiles. So, of course, we all know that textiles are a very demanding, environmentally demanding sector on Earth. A lot of examples we've heard one of the examples we've heard is that every second there's a truck of textiles being burned or landfilled. Of course, this is very unfortunate and not really desirable. So we are looking at how to implement a good solution for textiles that have already been used. So consumer use textiles or workwear use textiles. A first step in this process would be collection and sorting. And sorting in our example was primarily based on the materials that were part of the textile bunches that we collected. So we had a lot of polyester cotton blends, a lot of 100% cotton items, also items containing wool, and unfortunately, a large amount of these textiles were containing forbidden materials that needed extensive sorting or sometimes deconstruction. So, for example, reflective strips, a strip of parts of clothing that had metal fibers in them. Those are not really suited to mechanically recycle and make a new yarn of. So those have a separate solution. Those are mostly used for insulation purposes. So we have 3 different batches, for example, it could be 3 different batches, and all these batches, they end up with a different solution. So we could have a batch that is mostly polyester cotton blends, very easy, relatively easy materials to work with. And in the past, we have been able to, with the help of other companies, to create a fully recycled yarn containing of polyester, cotton, and partially wool. Where in the end also new fabric could have been new fabric was spun off, and those can have different appliances in a next use. For example, some material blends would be more suited to have a workwear implementation. For example, workwear trousers. And sometimes it's harder to make a fully functional product, so we end up more or less downcycling a specific product stream of a material stream, and filling or insulation would be a suitable solution for that. So also for this use case, the material composition is very important. We can show impact data on every single material composition. So every separate textile stream can be identified and have a separate impact calculation based on the KPIs Jasper mentioned earlier per kilogram, and we are able to sort out the next used applications and also add these to the digital product passports that come with each individual textile stream. Another example would be the use of personal protection, in this case safety shoes. So safety shoes are interesting in the way that they originally are not designed to be taken apart. On the other hand, in most situations, it's very clear how the supply cycle runs. A lot of the market in safety shoes is business to business. Users use the specific shoes for an extended period of time, let's say 2 or 3 years. So producers also know often when they're going to get their products back, and that makes them relatively interesting to set up reverse logistics and other circular processes. And the function of the passport in this use case would be component tweaking. So we could look at the specific safety shoe and see how can we create or alter a shoe that it can be taken apart and be taken into a recycling process. The materials are leading in this case, where we would like to eliminate as many as non-recyclable materials as possible, and that way have an insight in the environmental effects of these elimination as well. So we can make comparisons between a product before adding recyclable materials and after. And the third important factor would be reverse logistics. In the case of the safety shoes, we've set up the possibility to add QR codes in the tongue of the shoe, and that way consumers could scan the QR code and have information about reverse logistics on their phones, and that way the consumers were able to return the shoes to their producers, and that way it's way easier to, of course, set up recycling processes. So with this use case, we set up a clear path towards a fully circular process where also next steps can be identified, because in the end, also after completing this project, we still have materials that couldn't be recycled 100%. But there has been a clear path set, and you are also able to identify, okay, what are the components that I've been able to make recyclable, and what are the components left that has to be looked more into upon. Next, transparency towards customers and in their sustainability reporting is very important. So we could imagine that a brand would like to have a way to be transparent about the impact their products are actually causing, and that can be done with a digital product passport, because that also contains impact data. And lastly, we have a connection between the physical product, so in this case the safety shoe, and the digital product passport by the use of a QR code. So the QR code is one of the many examples we can set a specific connection with. You can also use a RFID tag, or there are other solutions available as well to make a connection between the physical product and the passport that you're using in this example. And our last example will be a furnishing of a supermarket, where we look at, for example, a projector/lamp. For this case, the request was to look at a more sustainable way to furnish supermarkets. So in the supermarket business, so to say, it's very susceptible to what the customer wants, to shopping trends. So most of these supermarkets are restructured, sometimes even rebuilt, mostly refurnished every more or less 7 years or so. Sadly, this is mostly based on linear models. So everything that goes in the supermarket, and then I'm not talking about the products, but the furnishing of the supermarket. After the 7 years of use, most of these furnishing would end up in landfill, and we try to redirect that to create a more circular way of restructuring these supermarkets. So we ended up creating 1,300 digital passports for every single item in regards to furnishing that was available in the supermarket, and that way capturing all of the elements. The specific example is a lamp that was made of a casing, a bracket, some electronic parts, and a light bulb. And we defined its material composition, calculated the impact automatically, and recorded the next used applications. So that way, when this item would become available after the use of, let's say, 7 years, we have a specific end-of-use solution for this product. Sometimes it could be just refurbished and be reinstalled. Other times, this specific product is suitable to be recycled and to be reused in 3D printable lighting fixtures. So that is one product example. Of course, there were a lot of other products in the supermarket as well. For example, the shelves, the floors, and the walls that were used were relatively easily either refurbished or recycled. By doing all of these steps, we had a 80% circularity rate. So the 80% waste became 80% circular, secured by the use of a digital product passport, partially also with the influx of the help of all the suppliers, of course. And that led to an 80 tons CO2 reduction per year. So we recalculated it into a per year amount. And of course, in some cases, within some products of the supermarket, the extended use period was able to be lengthened, or the use period was able to be extended, and that also resulted in direct savings as well as an impact reduction. So this formed a blueprint, so to say, for next step development, because both CO2 reduction and the extension of use period was actually a financial motive, could be seen as a financial motive. So this was for one specific supermarket, but one can imagine what if we would do this with every supermarket of a specific firm or brand in the Netherlands. And this also helped to convince other forces within the specific companies. So we have, of course, we see a lot of incredible companies for whom sustainability and circularity are no-brainers, and for others it might not be the case. So showing clear examples of success within an organization then can set up a transition towards more sustainability, not only internally that way, but also externally, because of course, a 18 tons CO2 reduction is very nice, of course. So this was it for the use cases, and then we would end up with this slide. Based on the environmental necessity to transition towards the circular economy, we believe we can only make this happen if there's a fruitful business models to support these sustainable efforts. Some examples are displayed here. So one could be product and material recovery. Of course, raw materials are very costly and are very scarce, especially in the continent of Europe. And recovering materials by organizing reverse logistics and refurbishment and recycling processes are essential for the economy as a whole. But doing so, we can save companies in terms of new investments as well. Another way would be buyback programs. Record terms and conditions for good buyback possibilities are a very nice example of a more sustainable way of function as well. And in this way, you would give the consumers the tools and information to keep products in the best possible condition, because only in that case a producer would buy back the specific products they have sold in the past to their customers. Products as a service is also a business model we've seen more in the past years, where customers rent their product instead of buying them. The consequence of this is that the producer and the owner of the products are more incentivized to opt for quality, so for a product that has a longer use time, and a more efficiently organized maintenance system. So a producer would look into ways to make their products more refurbishable, for example, or more easy to repair. And this way it becomes more easier to recover materials and use them in the next use cycle as well, since the materials are possession of the producer and not in possession of the clients or customers. And lastly, we also see some carbon pricing as a business model. And some sectors, so the larger industry sectors, carbon pricing is already in effect, and is likely going to apply to more and more companies over the coming years. By using the digital product passport and the automatically calculated impact, you can make better choices on what material to use, what material composition is more or better, to say it another way, in terms of what it would be an environmental footprint, in this case carbon. And of course, you can save in your emissions and consequently carbon pricing that way. And our passports include the possibility to calculate the carbon price based on the specific material as well. So that is part of the impact KPIs that we have in the digital product passport. So as a sort of way of summarizing what we have discussed today, we hope that you guys have taken some interest in what we would like to tell you. The digital product passport help circular products to fulfill their potential. with a form of transparency, with some insights, and also instructions. So these are the 3 key points of the use of a digital product passport. I think next up, we are going to thank you for listening to us. We have a next webinar also scheduled for December 7th on a Thursday. If you would like to request a topic, please leave a comment in the chat box. We have not decided on what to do, what topic to do next. So all influx is more than welcome. If you have any questions after the webinar, you can always send an email to info@cirmar.com or contact either me or Jasper through LinkedIn. If you're interested in looking at how as a digital product passport at Cirmar would function, or you would like to try out, we have the availability to have a free trial. You can just sign up at our website, www.cirmar.com. It's very easy. You can create a certain amount of test passports where you can have all functionalities and see how a passport actually functions and works. So I've already noticed some questions popping up. Jasper, have you managed to answer some of the questions that the attendees had?
Yeah, so I've answered almost every question that came up, and I just wanted to point out that there were 2 questions that we can give a little bit of extra explanation to everyone attending here. One interesting question was about creating standards and whether it makes sense to close individual loops instead of building up these universal standards that are applicable to every product. Well, the way I responded to that is that that there's different routes that you can take. We can sit back and wait for standards to be created by the European Union. Our experience is that this is a pretty painstaking process that takes a lot of time, and that starting in practice is much more fruitful. We currently see that our passport and others are being used in various sectors, and that the experience of working with these various sectors has given us a lot of input on what is strictly necessary to take up in the passport and what kind of information would be nice to have. So we're definitely following the development of these standards, but they don't exist yet. But closing single loops contributes to this process of creating these standards and giving input to the European Union. And another question was about the data. So that somebody asked whether this is the digital product passport is a global database from which we take information. It's a little bit more nuanced. We use global data that has been checked and certified by knowledge institutes about production, recycling, refurbishment of specific materials, and we translate that to the digital product passport. And that means that if you have a product passport of very general materials, let's say plastics, metals, plastics and metals, that gives you less accurate information because it has to be based on averages. And if you add very specific materials, let's say recycled polypropylene, you get the specific impact numbers of these materials. So that's 2 questions I wanted to highlight. And the others, I think, have been answered for as good as we can.
I think there's one question remaining I saw in the questions and answers box from Mariana, and she summarized, or I'm just going to summarize her question, is how we look at the possibility for the recycling of specific materials in a existing infrastructure, because that differs per country. So it can be hard to find possible solutions if you're looking into making a more circular supply cycle. So yeah, we encounter this problem as well. What we most of the time do is look at the certain supply cycle we have in mind to create. That is our goal for a specific product. and see if we can find regional or national solutions. Unfortunately, this cannot always be done. So sometimes specific materials come from the other side of the world, and that is those are often processes we can hardly avoid. But and a few solutions we would look at for a more regional or national solution. So fortunately, within the EU, and I think also within the Netherlands, Belgium, and Germany, we can find relatively good solutions to recycle materials in. But I think that will be the key process here, is to look at regional or national solutions. For the reason that it wouldn't be wise to look at recycling options very extensively located outside of your supply chain, even though that could be cheaper. It just wouldn't make any sense to have a material recycled on the other side of the world from an environmentally perspective, of course.
Okay, I think that that's a wrap. So we'd like to thank everybody for taking time to join us at this lunchtime webinar, and we're looking forward to future suggestions for new webinars, and you will receive all the relevant information that we discussed. So thank you, and have a great day.